In this video, I want to prove rigorously the following functional derivative, the formula for the following functional derivative, in particular, the functional derivative with respect to some function that I will call era sub b of x double prime, and we want to take this functional derivative of the derivative d mu era sub a, so we change this subscript of x. Now, in particular, it is convenient to rewrite d mu era sub a of x in the following fashion. So the partial derivative stays there, but then I can rewrite era sub a of x by writing an integral dx prime over dx prime of the convolution between the four-dimensional Dirac delta dx minus x prime. I say four-dimensional because I'm thinking that this dx prime is actually d for x prime, so I'm writing it compactly like this. In general, this can be n-dimensional, so in physics, for example, you encounter very often 4 dimensions, so this dx prime would be d for x prime, but compactly we are going to write dx prime. And then we have the Dirac delta of x minus x prime times era sub a of x prime. So the result of this integral is indeed era sub a of x. And at this point, we can take this partial derivative inside the integral because we have to take the partial derivative with respect to x mu. This would be d over dx mu. So I can move this partial derivative in front of the Dirac delta because it will act on the Dirac delta, which is the only function that depends on x. So this is equal to integral dx prime. Let's put era sub a first of x prime d mu of delta of x minus x prime, like this. And now when we take this functional derivative, the functional derivative will act on this integral here. So basically, the functional derivative will only act on this era sub a of x prime, and it will create the following result. So we will have delta a b, which is given by the fact that b should be equal to a if we want a non-zero result, and then we get another Dirac delta of x prime minus x double prime, because otherwise this derivative will give a zero result if x double prime is not equal to x prime. And then we are left with this partial derivative, so we have d mu delta of x minus x prime. So at this point we can evaluate this derivative at x prime equal to x double prime because we have this Dirac delta, so we can replace x prime with x double prime here, and then we can integrate this delta, which will give us 1, so we are left with delta ba d mu delta of x minus x double prime, and this is a result of this differentiation. And it is something quite intuitive if you think that you can move this partial derivative in here, and then you take this functional derivative of this era sub a of x. But in this case, we have proved it more rigorously, and it yields this result.